Good morning, students. Here we will discuss metal casting process. We have already discussed in last 3 videos about this metal casting process. Various types of casting processes are there. But to cast fast we need a pattern. And these patterns are dimensioned or designed considering the type of casting. And here certain casting defects are avoided and certain dimensional accuracies are provided by giving pattern allowances. So, what is pattern allowance? The pattern is the replica of the required object. But when the pattern is prepared, the pattern should be made larger as compared to the required size of the casting. This difference between the actual size and required size is known as pattern allowance. So, different type of pattern allowances are considered. The first one is shrinkage or contraction allowance. So, during casting, a molten metal is poured into the mold. Here, sufficient time is provided to solidify. So, during this cooling from pouring temperature to room temperature, certain contraction takes place, or the metal is contracted during cooling from pouring temperature to room temperature. This contraction takes place in 3 forms: liquid contraction, solidifying contraction, and solid contraction, depending on the stage where the contraction occurs. When the contraction occurs in the liquid state, it is known as liquid contraction. And during solidification, the contraction takes place is known as solidifying contraction. But after solidification, to achieve the room temperature, that metal gets further contracted. That is known as solid contraction. The first two contraction, liquid contraction and solidifying contraction, are compensated by providing gates and risers in the casting design. While we are discussing about sand mold casting, we have already seen in the mold there is a provision for gate and riser. So, these gate and riser are provided to compensate shrinkage during liquid stage and during solidification. But the last shrinkage, that is solid shrinkage, is adjusted by providing adequate allowances in the pattern. The shrinkage allowance in the pattern varies with variation in casting metal. Next is draft allowance. Draft or taper. Slight taper is provided on the vertical surfaces of the pattern so that it can be removed from the sand without damaging the sides of the sand mold. This taper is known as draft allowance. It can be expressed in degrees. So this is the diagram of taper in the pattern. So in the first picture there is no taper, so the casting is distorted. But in the second picture there is a taper, slight taper in the side wall of the pattern. So it is taper casting, a picture of taper casting. First one is shrinkage allowance, second one is taper allowance, third one is machining or finishing allowance. As we have discussed, after the casting is ejected from the mold, it has to be cleaned and machined. So during this machining, certain dimension will be reduced, as the machining is a metal removal process. So considering this metal removal, pattern size should be made little bigger than the required size of the casting, because after machining we will get the exactly same size of the casting. Ferrous metal need more allowance than the non-ferrous metal, considering machine allowance. Next is distortion or camber allowance. Sometimes castings get distorted during solidification due to their critical shape. So this is because of the critical shape the casting get distorted. So from practice or from experimental observation, so this defect is pointed out. Non-uniform contraction of casting during cooling causes thermal stress, which also results distortion. So to compensate this distortion, camber allowance is provided, or in other words, to eliminate this defect, an opposite distortion is provided in the pattern so that the effect is neutralized and the correct casting is obtained. So these are the pattern allowances. This is the diagram of distortion or camber allowance. So the required shape is given in the first diagram. With practice, it is observed that this is the distorted casting. So the pattern is given the negative camber, so that after distortion the required shape will be obtained. So next is wrapping allowance. Wrapping means shaking the pattern from side to side so that its surface may be free of the adjoining sand wall of the mold. By this action, the volume of the mold cavity increases. The pattern size should be little smaller as compared to the casting size to compensate the increase of mold cavity due to wrapping of the pattern. This negative allowance is known as wrapping or shake allowance. Next is mold wall movement allowance. Movement of mold walls in sand molds takes place on account of the excessive heat and the static pressure exerted on the surface layer of sand. which comes in contact with the mold metal. Due to contact with liquid metal, high heat and the static pressure is exerted on the surface layer of the sand, due to which mold walls get some movement. When this movement is not controlled by controlling the density and temperature of the molten metal and composition of the molding sand, alliance is provided in the pattern to compensate this difference in volume due to wall movement. So this is known as wall movement alliance. So these are various pattern alliances which are to be correctly calculated and provided in the pattern to get the exact dimension of the required casting. So this is all about patterns and pattern alliances.